What is fog? One question that I often get, or a misunderstanding that I often see, is with regard to the definition of what fog is. Now, the definition is important, of course, but it's particularly important when it comes to trying to collect water from fog. It's important to know what fog is and what fog isn't. So I want to begin by saying the most important consideration is that fog is liquid. It is not a vapor. Fog does not condense on surfaces. That is a common misunderstanding, and it leads to problems, I think, in terms of trying to collect water from fog. In order to collect water from fog, fog has to exist. For fog to exist, it means that it's tiny little particles of water that make it difficult to see a given distance. So the particles of water being higher, so that sometimes we say it's fog when it's a low cloud, that isn't enough. It has to be at the ground level so that somebody 30, 40 feet in front of me is looking like they're in the clouds, it's wispy. I can see the little wisps of the liquid droplets between me and them. That is fog, and it has to be thick enough in order to collect from it. So that is an important consideration, and one of the first things I want to say. But specifically, what is fog? It is droplets. The droplets are somewhere between 1 and 50 micrometers in diameter. A micrometer is a millionth of a meter or a thousandth of a millimeter. Your hair might be have a diameter of about 100 microns, depending on the thickness of your hair. So fog is typically thinner. It is thinner than most people's hair is wide, the diameter of a fog droplet. So that is the droplet size associated with fog. The other characteristics of fog are that it reduces visibility to no more than 1 kilometer. So if you can see somebody, if somebody's a kilometer away from you, you can't see them because of the stuff that's in the air. That stuff is possibly fog, assuming it's not smoke or something else. And the other definition of fog, which is very vague, is that it's a cloud in contact with the ground. So fog is, in a sense, a type of a cloud, although it forms in a slightly different way than clouds will form. For fog to form, you need several ingredients. One, you need a source of coolness, or the absence of heat. And for two, you need something that's warm. It's that gradient, or the difference between the warm and the cold, that's needed to produce fog. But in addition to that, you need a source of moisture, which can be water vapor that exists, let's say, in the warmer body of air, or in the warmer object, or in the ocean, if the ocean is the cooler object and the air above it is warm. You have a source of moisture, you have a temperature difference, and you also have to have tiny little, what we call condensation nuclei, or tiny little particles. They could be bacteria, they could be salt crystals, they could be dust that's in the air. Rain needs the same thing. In order for water to condense, which is what has to happen in order for fog to form, it doesn't condense on you, it condenses on the droplets. You have to have these tiny little nuclei. Condensation nuclei is what they're called. So with those ingredients, you can create fog, or fog is created, I should say. The challenge then is, of course, there's different types of fog. Some types of fog are easier to catch than others. We have what's called advective fog. It's fog that's formed over the ocean typically, cool ocean, warm air, and it's blown into the land, advected onto the land. It could be called a coastal or an advective fog. That's one very common type of fog. And it's one of the types of fog that I try to collect water from, since I live in Monterey, which is a coastal environment. Another type of fog is orographic fog. That's when air masses rise, and in rising, because of the pressure difference at height, air cools as it gets higher, typically. And as it cools, cool air holds less moisture in it in water vapor phase than warm air. And if there's particulates, which there typically are, you'll have little droplets forming, and that's basically fog forming, or you could say it's low clouds forming. But since it's in contact with the ground, from the perspective of a fog scientist, I would call it fog, because I could potentially collect it. That's actually some of the richest fog in terms of the amount of water available. If you have mountains near the coast, you have advective fog that can be blown up the slope of the mountain and create an orographic fog. So it's kind of a combination of advective and orographic. You can have the same thing inland. You can have orographic fogs inland, clouds on mountaintops. to the on top of the mountain, that may look like fog and could be collectible. There are other types of fog. You can have fog created by a warm ocean and cool air. That would be a steam fog is what that would be called. You can also have something called radiation fog, which is similar, or which is a type of fog that's formed, for instance, in the Central Valley of California, over fields where the ground is cool at night. It gets cool at night because of the radiation of the heat into clear sky. If there's a clear sky, that can happen where the ground gets cool. And the coolness of the ground combined with the moisture present in the ground and the temperature difference between the ground and the air creates this rather stable fog that's not being blown by wind or anything. It's very still typically. It's also very dangerous for transportation. So that's called a radiation fog. It's more difficult to collect water from that type of fog because the droplets are typically smaller, so they hold less water per droplet, and there's no wind to really blow them through something. So you're not going to probably collect as much water in a radiation fog as you will in an orographic fog, for instance. So hopefully that gives you some background on the different types of fog and some idea of what fog is, particularly if you're planning to try to collect some of it.